Okay, good. So let's start. This is Emre Kızılırmak with Winncom Technologies, and today we will talk about comparing radios over datasheets. We will go over some of the important attributes of the radios mentioned in the datasheets, and we will see how it affects the performance of the radios. Please feel free to ask your questions in the question box during the presentation, and we will get back to them in the end of the presentation, okay? So today we will be talking about duplex communication and duplexing schemes. Then we'll talk about throughput, link symmetry, and channel sizes, modulation, receive threshold. Then we will move on with the transmit power and antennas. Then we will talk a bit about the QoS support of the links. Then multicast traffic, which is quite important for the IPTV, and powering mostly about PoEs and the physical interfaces of the radios. Okay, there are two duplex communication methods, is full duplex and half duplex. For full duplex communication, that both ends of the link can send and receive signals at the same time. And for half duplex communication, that ends of the link takes turns to send and receive the signal. In radios, there are two corresponding methods in use today. They are FTD and TDD. You can find which method your radio is using on the datasheet. Just keep in mind that some radios can also support hybrid methods. That is most of the time a TDD system on two different channels for each radio. If we compare TDD and FTD methods, the main difference is TDD is using a single channel to communicate, and FTD is using two channels. Since it's a single channel and divided with the time, TDD can provide you different uplink downlink ratios. However, on an FTD system, uplink and downlink ratios are always fixed and it is symmetrical. So TDD is mostly common in the unlicensed bands and FTD is common in the licensed bands, since it is more defined in the licensed bands. The most important thing I want to say about TDD versus FTD on a datasheet is the throughput definition. In a TDD system, throughput is defined as aggregated throughput. It's uplink plus downlink. On an FTD system, the throughput is defined as uplink and downlink, since they are equal, since the link is symmetrical. So if we are talking about the 400 megabit link, then if it is a TDD system, it can be 200 megabit uplink, 200 megabit downlink, or 100 to 300, or anything else the radio can support. However, on an FTD system, if we are talking about the 400 megabit link, it means 400 in the uplink and 400 in the downlink. Okay. Talking about throughput in the datasheets, we almost always see an expression says up to in front of the throughput information. This throughput information can be accurate, but it depends on some criteria. It's in the best case scenario. It must be on the highest channel size, must be using the highest modulation, in a lowest distance, and no interference, no multipaths, or any other negative effects on the link. Talking about throughput, we need to talk about link symmetry options as well. Just keep in mind that this is only applicable for TDD links. FTD links are always symmetrical. Supported ratios are available in the datasheet. Depending on your application, you will want to choose a radio that will fit your needs. If you are using the link for providing internet, you may choose a higher download ratio. But if you are using it for, let's say, CCTV application, you will need more uplink than downlink. So for your application, you may either choose an FTD or TDD link, and within the TDD links, you can choose a link that will suit your project better. according to the link symmetry options. Okay, I think this is the most definitive attribute of a radio performance, the spectral efficiency. Spectral efficiency is calculated as throughput over channel size. Okay? So if you have a let's say 750 megabit throughput on a 80 megahertz channel, your spectral efficiency is like 9.4 bits per second per hertz. Okay, it means it can carry 9.4 bits per second in a hertz. And for a 450 megabits, if your channel size, highest channel size is 45 megahertz, it means your spectral efficiency is 10 bits per second per hertz. So if you compare these two radios on the 40 megahertz, a common channel size, for the first radio, you will get like 375 megabits per second. And for the second radio, you will get 400 megabits per second. So even though on the datasheet it says 750 megabits, it requires a much higher channel size. And even though the other radio says it can deliver 450 megabits, it does it in a smaller channel size. That gives the performance of the radio. Okay, a few words on the modulation. The higher the modulation gives us more throughput, definitely. But the trick is, the higher your modulation, the higher your receive threshold. So you will need a much cleaner signal to have a high modulation. And it most definitely means that you can have higher modulation in a closer link. Far apart links, you will not get that much high modulation levels. So your receive threshold defines the modulation type you can use in that distance. Remember, we just talked about that the higher modulation, the higher the required receive threshold. So let's try to compare two radios on these charts, okay? Let's say our 20 megahertz channel on minus 71 dBm receive power. With the radio on the right, you will have only 0.4 dBm fade margin. And with the radio on the right, you will have 3 dBm fade margin. Fade margin is important because it defines the stability of your link. If you temporarily lose some of RF power unexpectedly, it can be anything like interference or something else. The fade margin will protect your modulation level, and you will not experience a lower throughput because of the loss. So the higher is your fade margin, your link will provide a higher stability for that modulation level. We see another of the expression in the data sheets where we see the transmit power. Okay? The higher your modulation, the lower is the maximum transmit power you will get. However, this may not be an issue if your regulatory body is forcing you limiting the transmit power or the ARP. ARP is the power that we radiate over the antenna to the air. And the calculation is you simply add your gains and losses to get the ARP level. So you have your transmit power, then your loss on the RF cable that you connect your antenna and the radio, and the gain on your antenna. When you add all these, you get your ARP level. Just keep in mind that the transmission loss is 0 for integrated antenna radio, since there is no cable to connect the antenna to the radio. The ARP levels are generally limited to 30 to 36 dB range by the regulatory bodies. So if you have, let's say, a 27 dBi antenna, integrated antenna, you will have 3 dBm transmit power only if your limit is 30 dB. But talking about antennas, on the datasheets, you can see various options for the radios. Some come with integrated antennas and some come with no antennas, but connectors only. You cannot change your antenna size for an integrated antenna model, But if you use something like a reflector or a horn with the integrated antenna, you will need to add its gain to your ARP calculation as well. If your radio comes with connectors instead of an integrated antenna, you must be careful with the connector type. There are various RF connectors available, but most of the time, you will see either an SMA type connector, N type, or RP SMA type connector on the radios and the antennas. You must choose the connector type on your RF cables in accordance to the connector type on the radio and your antenna. Okay, the quality of service. QoS is a comprehensive topic, but let's have a look at different QoS methods to have an understanding of the difference. Okay. First, the priority queuing is strict priority with 4 levels. If there is something in the higher level, it will pass it than the other lower levels. With the custom queuing, it is using a weight round robin algorithm. It's using weight values to provide more or less packets for each of the queues. The weighted fair queuing is quite common in these days, especially in the cheaper range radios. It checks the traffic to determine the priority of the traffic and assigns the weight accordingly, but there is no user control on this weight method that you cannot assign them manually. However, in class-based weighted fair queuing, you can assign weight values by yourself. The last one, low latency queuing, is about adding a strict priority level to the class-based weighted fair queuing method. How your link handles the QoS may not be a problem for most of the networks, but if you will have critical communication over your radio, you may want to check how your radio handles the quality of service. Okay, this is important if you are providing IPTV or your point-to-multipoint radios. Let's have a look at the multicast traffic first. What we are talking about. Multicast traffic, multicast is used for delivering the same packets to multiple recipients with the same address. Okay, it is using user destination groups, and every device in these groups have a single IP, multicast IP. So when you send a packet with that multicast IP, every user in that group will receive it. So you will not be sending the same data with single packets to each user. If you are using a point-to-multipoint system to provide IPTV to your customer, let's say you're an ISP, and you'll be also providing, let's say, internet and voice over IP or whatsoever, in that case, it's a good idea to check how your radio handles your multicast traffic. There are different methods radios are using. Most of the time, you can set the priority accordingly, or you can set how it will be handled in the RF side, like the modulation levels, etc. Okay, powering the system. At the moment, most of the links are using PoE, Power over Ethernet, but there are some radios also using the direct power connections. In that case, we need to check the power cable specifications and the connectors on the radio. But if it is PoE, you will need to understand the difference between the active PoE and the passive PoE. If your device is a passive PoE device, your radio is a passive PoE device, there's no negotiation between the powering device and your radio port. So whatever you give, whatever the voltage you provide, your radio will receive it. So if you connect something wrong, you can easily burn down your radio, or at least the port. However, in the active PoE, there are very defined protocols, 802.3 standards that set there, and if your radio is using one of those, it will negotiate with the powering device, your PoE device, and it will get the power accordingly. Okay, lastly, a few words on the physical interfaces. You may see different interfaces, but most of the time, you will see at least a gigabit copper port at the moment. I mean, it's a PoE device. You will see that copper port is also used for the PoE as well. You may have an auxiliary port, a second port on your device that will power up, let's say, a camera that you connect to your link directly. So you'll not need to add any additional cable and PoEs in the field. And you may also have an SFP port to use mostly with fiber, also available for copper as well. But just to keep in mind, to use the SFP port, you will still need to power up your device. And if it's a PoE device, you will still need to install the Ethernet cable, copper Ethernet cable as well. You can see other various ports on the radio, like a management port or a headphone jack to hear the alignment tone during the installation. These can come in various types. It can be a headphone jack, it can be an RJ12 or some other connector. But most of the time, you will see either an RJ12 or a headphone jack, or maybe sometimes some connectors for your multimeter to see the voltage for the alignment. Okay, this is all with the comparing radios on the data sheets that we will talk today. If you have any questions, please type them in the question box. Okay, I don't see any questions, so thank you very much, everyone. We are finishing today, but please feel free to contact me anytime for your questions, and I'll be happy to help. Stay safe and have a good one.